Okay, so yesterday we did an introduction to torque, and torque is just the rotational equivalent to force. So it's the force that is acting on an object that makes it want to rotate. Okay, so we talked about a torque, about a door or a diving board. So today we're going to talk about net torque. And so if you remember back at the beginning of the year, we talked about the net forces. So here's our force net right here. And net force just equals to the addition of all the forces. Okay, sometimes you'll see this sign here, sigma, and that's a Greek letter, and that just means add them all up. So I can say the sigma, or the sum of all the forces, is going to be F1 plus F2 plus F3. And these would be the force F1, F2, and F3. So we could add them up. So the net force is actually equal to the sum of all the forces, which is sigma. So we're going to do the same thing with our net torque. So I can say that sigma, which would be the sum of all the torques, is going to be equal to the torque based on force 1 plus the torque from force 2 plus the torque from force 3. And we just add all those torques up to find out, well, what is the net torque on an object? Okay, so the main difference when we add torques up versus adding forces up is that we talk about torque about an axis of rotation. So force, I just added the force ups. For the torque, I would have to say the torque about this point right here, or I could say the torque about that point, or the torque about this point. But we always say torque about a point. So we have to have it rotating about a point. And that's because we have torque is about an axis, and that's what we're going to be talking about. Okay, so this lesson is actually really short. We're going to start right away with an example. Okay, we have a weightless board, so this is a board that has the following forces applied to it. So we have 4 newtons going down, we have another 8 newtons going down over here, 6 over here, and some unknown force, F, that's over here. So we want to know what is F so that the board is in equilibrium. Okay, so for board to be in equilibrium, that means that the sum of the forces, or the net torque has to be equal to 0. We want it in equilibrium. So how are we going to go about finding the torques? Okay, what we're going to do is we're going to calculate all the torques, and we're going to find out what that value is. So we can pick any point. So to make things easy, I'm going to pick it about right at this point right there. So I'm going to say the sum of the torques about that point is going to be equal to 0. So now I want to add up all those torques. So I'm going to start here on the left. I'm going to start with this 4 newtons. I know that the force is 4 newtons. The distance from here to here is going to be the 4 centimeters plus the 6 centimeters, which is 10 centimeters, which is 0.1 newtons. Okay, and the angle between this force and the distance is 90 degrees, so we have sine 90. Now to find out the sine, plus or minus, what I have to do is if this were to push down here, it would cause this board to rotate in this way, which is counterclockwise, so this is a plus torque. Now we're going to go to this 8 newtons. So we have 8 newtons is the force. The distance that this is from this point is 4 centimeters, or 0.04. Oh, this isn't newtons, I'm sorry about that. That's 0.1 meters, 0.04 meters. And then once again, it's 90 degrees, so we have sine of 90. Now we have to find whether it's positive or negative. So if 8 newtons were to push down on this board, it would cause it once again to rotate in this direction, which makes it plus. Now we're going to go to the 6 newtons. So our force is 6 newtons. The distance that this 6 newton is from that point is 5 centimeters. So we have 0.05 newtons, or I'm sorry, 0.05 meters. Once again, it's sine of 90. And now we have to find out whether it's positive or negative. So 6 newtons is going to push down here, which will cause it to rotate this way, which is clockwise, and it becomes a negative. Now we have to add one more. We have the force that's unknown times the distance, which is 5 centimeters, and 5 centimeters, which is 10 centimeters, or 0.1 meters, sine 90, and we have to find out if this is positive or negative. So if F is pushing down here, it's going to rotate this way, which is clockwise, which means it's negative. So if we figure all this out and we set it equal to 0, we end up, these all end up being 1, so they